Hey everybody, in this video I'm going to go over quadratic functions, how to get them from looking at a table or a graph. Okay, so this first example here is what you're going to do is you're going to go through the graph and you're going to look to see where the nice points are. Okay, and this graph didn't print all that well, but you'd put points here, 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 and here, and you'd put them in your table there. So it's going to look like this. All right, so I have everything. I drew my dots on there, and then I made my table. Okay, so once you make your table, then you need to go to your calculator. So what you're going to want to do is you're going to want to add a list and spreadsheet. Okay, you're going to want to title it. Most people just title it X and Y. Okay, so you could do X here and then Y there, and then type in all your data. Okay, so let me show you what that looks like with all your data typed in. Okay, so here's everything typed in. All right, so what you want to do next from this to get your function, add a document page. Calculator page. So to do that, you do Control Doc 1. Okay, and the nice thing about that is it's linked together. So you're going to go to Menu, Statistics, Stat Calculations, and there's this whole big menu. We're doing Quadratic Regressions. Okay, so your X list will be X. I typed in X. I typed in Y. Press OK, and you get this. All right. So this one, it's not perfect, but you see your A is this, your B is that, your C is that. It's in standard form. So on the notes, I did put standard form is right here. And then I did also write down all the steps that I just did. So once you get this, round to the nearest like 3 decimal places, and that's what I did here. And so I wrote y equals negative 17.347 x squared plus 52.041 x minus 0.459. And then to answer the next question, what is the height of the ball at 2.25 seconds? Well, I got 28.8. How did I get that? So once you have this, like I said, everything's linked together. So hit Control Doc and go to Add Graphs. When you press that up button, there's the function. Nothing's rounded. It is exactly as it was right here. So everything, it's graphed. There's no rounding. And if you want to find an exact value, you got to go to Menu, Trace, Graph Trace. And with this, you can type in any X value you want. So if I want to know where is it at 2.25 seconds, that's how I got the 28.8. So there we go. Now, let's go over the rest of this because as I was talking about this, I realized I skipped 1 through 7. So let's talk about what this graph means. The x-axis stands for time in seconds. The y-axis stands for height of the ball in feet. So this guy Luis kicked a soccer ball, and this is the graph of it, okay? So the starting ball, you kick it from the ground, so it's at 0, 0. The ball reaches a maximum height, so where's your vertex? I put about 38 feet after 1.5 seconds in the air. If you go back and you look at your function at 1.5, it says 38.6, so we did a pretty good job of rounding there. And then the ball returns to the ground after 3 seconds in the air. Yeah, that's where it hit 0 again. How long was the ball? At least 20 feet off the ground. See, I wrote 2.5 minus 0.5 equals 2. Because here's 20, and there's 20 again. So I just figured everywhere from here to here, it's off the ground. So that's 0.5, that's 2.5. That's how I got 2 seconds. And then what's a reasonable domain? So normally for quadratics, it's all real numbers, but this is a motion graph. That wouldn't make sense. So the ball was you kicked the ball at 0 seconds and it was in the air for 3 seconds, so 0 to 3. The smallest to largest height, it wouldn't be 0, 38, 0. It's smallest, largest, so just 0 to 38. And that's how you get your range. Okay, so that pretty much covers everything on this first one. On the second one, similar thing. You got you kick a ball or something, and this is the time in seconds. This is the height of the ball. So what I did was I put little dots, where it passed through the corners. Those are good points that I could graph, and I wrote it down on my table there. Okay, so I went to my graphic calculator and I typed it in. And so for this one, I use XX and YY. So here's everything typed in. All right, I'm going to go Control, Doc 1, and then I'll go Menu 6, Statistics, Stack Calculations 1, and then number 6, Quadratic Regression. And so in this one, you can click this arrow or you can actually type in the letters yourself. I could type in XX. You can hit Tab to move on, YY, and then just click OK. And so here you have -2 for your A, B is 14, and C is 0. So for my answer, it's -2 for the A, right? -2x squared. 14 was the B, so plus 14x. And then you could write a plus 0 there, but why do you need to do that if it's just plus 0? So there's my function. What's the height of the ball after 6.5 seconds? Okay, again, I added a graph, and then, like I said, just press up. And there it is typed in, but you see how it's not checked? So you just need to press enter, and now it's typed in. And so when you go to menu 5-1, type in any number you want. The question was asking 6.5 seconds, so I'll type in 6.5, and there it tells me it's at 6.5 feet. So that's how I got 6.5 feet. I did it again. I skipped everything. The starting height of the ball is 0. The ball reaches a maximum height. I wrote 24.5. You can see it goes by 2s. And so it's not quite at 25 in my opinion. So that's why I wrote 24.5. And I notice how I didn't put the vertex in there because I'm just estimating it. These other points I didn't have to estimate. They were spot on. They went right through the corners. But yeah, looking at it at about 3.5 seconds, it does seem to go about 24.5. And with the function that was given to us, if I type in 3.5, hey, look, 24.5. So I did a pretty good job estimating there. The ball returns to the ground after 7 seconds. You see that there. How long was it? At least 12 feet off the ground. Same thing before. I basically drew a line here at 12. And so it's at 1 second, 6 seconds. So it's been 5 total seconds in the air. How high off the ground was the ball after 3 seconds? You could tell that from the graph. 3, go up, it's at 24. If you wanted to use the calculator, type in 3, it says 24. You could pull up the table, Control T, but the table only gives you whole number values. So when I ask you something like 6.5, using that menu 5-1 is really beneficial. But yeah, that's all I have to say about this. Oh, I skipped number 8. So it's not all I have to say about this. The domain was 0 to 7 because it was off the ground for 7 seconds. The range was 0, y 24.5 because that was the highest point, 24.5, and 0 is the lowest point. So now I'm done. The notes are over. So I hope this video helped. Use the table for any time it's quadratic and you don't know what the function is. Plug in the table, you can get the function. Okay, this video comes after the vertex and the intercept form notes. So if you're given a vertex or x-intercepts, you could do it by hand like that. You could also check your work by just plugging in those 2 or 3 points given to you, and then the calculator will spit out a function, and it'll look different than the intercept form one. But if you graph the intercept form one and the standard form one, you should see the same graph. But yeah, so what this calculator does is it gives you the standard form one. Other than that, goodbye, everyone.